All right. All right, everyone catch the lesson last time? Good, good. Complex plane. And your homework said like a little bit off. Like you're not getting the homeworks off on yours?
I guess it was something that I showed a bunch of people. No one really understood what they were looking at.
All right.
The explanation that they have in there is
Oh,
the
okay.
question's pretty easy, but the explanation is trash.
Yeah. So am I fine? I didn't watch a video, but I understand I did all the homework problems. So am I fine?
As long as you can
Because
do
I did
the
not
objectives.
have time to watch the hour-long
Yeah, if you can do the
video.
questions, that's good. Yeah, I don't really have a way of checking, but.
Okay.
All right, cool. Yeah, so you guys said it, but just a reminder, next Thursday, exam 3, and then the week after that, so 2 weeks from this Thursday, final exam. Finally getting there. All right, moving right ahead because behind time as usual. Vectors. So a vector. What is anyone know? Any experience with vectors before?
Vector is a heading and a magnitude.
A heading. What is a heading?
Sorry.
I know what a magnitude is. From.
Angle.
Okay. All right, so a vector, depending on where you use it, which they have a lot of uses in different sciences, so computer science versus physical science and other sciences I don't know about. A vector has different interpretations. But for us and entry to what a vector is, it's a piece of information that really has like, well, two things associated with it: a direction and a distance. And one way we visualize it is using a what we call a tail to head ray. So as like a quick example, if I walk 3 miles east and then 4 miles north from that point, I'll do something like this. So 3 and then up 4. This right here. So we'll call that the tail. And this is the head. So tail to head. And that object right here from geometry is called a ray. And it's a vector. So they're kind of, I don't know, so simple and yet so abstract, but it's like a shift in a way. It's information that says how far you are from a starting point from your tail, and the direction made. Awkward. Let me further build on this. So this vector typically denoted with V, or U is also pretty common, but V is the most common. It's written like with a V with a ray on top of it. And it has many, many notations. So one way we might write this is write 3, 4 to represent going 3 units in the east direction and then 4 units north. It's not an ordered pair, although it kind of acts like one in a way, right? So the ordered pair is this point, but the vector is literally that, and it has 2 pieces of information associated with it, a distance and an angle. So the distance, very similar to what we saw in the last lesson, often called the magnitude, is written inside of 2 vertical bars, not one, like complex plane, but 2 vertical bars. And in this case, it would be the square root of 3 squared plus 4 squared. So at the end of the day, 5. So this vector has a magnitude of 5, a distance of 5 from its tail to its head, and the angle, which nothing fancy here, also similar to last lesson, can be expressed as tan theta is 4/3. So we would need the inverse of that, which is approximately in degrees, yep. 53.1 degrees. And that's kind of it in a nutshell. Introduce what a vector is. So it's a quantity. Actually, it's 2 quantities. It's a direction and an angle. One way to write it is in this kind of bracket notation. If given that bracket notation and you're asked to find the magnitude, it could be said in words or expressed in symbols. But at the end of the day, you're really just hitting it up with Pythagorean theorem. And similar to like the complex plane, you're basically finding that absolute value distance.
Do you think it's easier finding, the arcsine, arctan, or cos, doing the tan method, doing the arctan first, or do you feel it's easier?
Now that we have it's usually, you could use arcsine or arctan once you have this magnitude, but we typically, like, textbooks don't express that. It's not wrong, because we're just trying to come up with a formula that just uses the given information of a vector. So just like 3 or 4. I wouldn't say it's easier. It would be less work if someone just said, what's the angle? And you wanted to use arcsine or arccosine, you'd have to find the magnitude and then use the respective one. Whereas if I just wanted the angle of this vector, I don't need to find the magnitude. I would just take the y component over the x component there and slap it inside of arctan. Does that answer your question?
Yes.
Is it? All right. Cool. So if you had no experience with what a vector is, that's what it is. Just, I keep saying a quantity, but it's really 2 quantities that represent a distance and a direction. Okay. Definitely not in our textbook. But vectors as earthquakes. It's a silly analogy, but it'll help visualize or understand something that's about to come up. So suppose I have this house right here in this village, and horrible earthquake comes and shifts this house way over here. Boom. So what is the vector that did this? Well, we would need some information. Suppose I say this earthquake shifted this 12 units that way, 5 units that way. Boom. There's the vector that created the shift. Okay. And I'll call that V. Vector V is 12, 5. And in this unfortunate village, it gets slapped with another earthquake that will shift it, let's say, over here. So I will tell you that this distance is anything I want it to be, 4 and 1. I'll call this U. Let me put this as 4 and 1. As you might anticipate, I used the -1 to represent shifting downwards. And at some point, I probably won't draw any more earthquakes or diagrams, but it is definitely possible to shift westwards, and we would just have a negative in this position. So first, this is your horizontal shift. If it's positive, it's to the right. If it's negative, it's to the left, just like an ordered pair. This is your vertical shift. If it's positive, it's up. If it's negative, it's down. Pretty simple. Okay. Does this make sense? And if it does, what should the answer be? Does it even make sense to add vectors? Yeah. Okay. What would it be in the context of the story? 16, 4. That would be the answer. But what would it be in the that's true. So you're giving me the answer. What would the context be though? Like what would this represent?
So like the house started at its first position and then to its last position moved a total of 16 spaces east and 4 north.
Yeah. So basically what you're telling me, he's giving me the exact value and you're saying basically this just shortened basically represents the overall shift of 2 earthquakes. So if you started here and your village got hit with this earthquake and then another earthquake, then it has some context. It does make sense to add 2 vectors and it would represent the overall or the net shift. And if we just go with our human instinct, as Roman said, it's as simple as adding the x coordinates. The overall shift would be 16 units to the, which direction is that? East. And 4 units north overall, found by taking 5 and adding -1. Boom. There we go. Vector addition, mad simple. You just add the x components, you add the y components, and there we go. And what's the interpretation of it? Well, if a vector is an earthquake, its interpretation is the net shift from where you start to where you end. Does this have interpretation?
Yes, it does.
Yeah. What does it mean in the story? What does it mean in the context of like what happened?
An earthquake hits, the house moves. An earthquake of almost the same quality hits,
Same quality
and it
doubles.
moves at the same amount.
I would disagree, but you're almost there. It's exactly the same quantity. You're having two of the exact same earthquakes, so not almost the same.
But two earthquakes of the exact kind have to have different properties to them.
No, this is my story. Two, me, have to be exactly the same. It's exactly the same earthquake. Yeah, so that's the interpretation. It would just be like this earthquake happening again. So it shifted 12, 5, and then 12, 5 over here. Overall, so I'll say that represents two of the same earthquakes. Poor village.
Is it possible, like, you could be more creative with your stories with us? So I feel like as a class, we learn better when we, like, put in, like, other, like, theories or hypothetically, like, I don't know how to explain it, but I feel like
Roman
as a
story
class.
Wait, you don't like my story?
No, I'm saying a little. I'm saying you
Oh.
should make more of them.
Oh, okay.
I feel like as a class we interpret it better, like as stories compared to just normal math.
Yeah.
Anyone
Two-
who have pictures and pop up ones.
Two earthquakes. Cool. All right. So moving right along. What is a vector? Has two quantities associated with it, a distance and an angle. Can we add vectors? Sure. You just add the horizontal components, add the vertical components, end of story. I'm going to use a word here because something's coming up. Can I multiply by a scalar? That's what this is called. So going back to the word scalar, easy analogy, on a photocopy machine, you have your prom picture or your parents' anniversary picture, and it's this big, and for a gift, you want to blow it up. So you're going to scale it. You're going to enlarge it. Everything gets bigger. So you might double it. You might triple it, or vice versa. You could, for whatever, maybe make wallet size photos. You would half it or quarter it. So we're multiplying it by a scalar just means we're multiplying it by a number, because in just a minute, we're going to talk about a vector times a vector. And does that make sense in this story? But this is a scalar multiplication. And yeah, two of this represents two of the same earthquakes. It would be like V plus V. And so therefore it'd be 12 plus 12 and 5 plus 5. Or we could just say it's 2 times 12, comma, 2 times 5, which would also give us the same answer. So before I move on, summary time. What's the formula for this?
Square root of a squared plus b squared.
What's the formula for this? Let's say x1, y1, and this is x2, y2. What's the formula for this? And what's the formula for that? What is this called? First of all, what's the vocab word associated with this? Magnitude. And how would we find that?
I already said it.
Pythagorean.
Pythagorean theorem, x1 squared plus y1 squared underneath the root. The angle, actually I should say, let me do this. How would I find the angle of vector v?
You could do tan of y over x.
Yep. I actually do want to do this. If you watch my video, I explain why I don't want to call this arctan. Why don't I want to call it arctan?
You're really messy.
We'll come back to it. Okay. But it has to do, arctan only returns, when we go back to our inverse trig conversation, a quadrant 4. David calls it the negative quadrant 1. All good. I get what he means by that. Or a quadrant 1 angle. But if I have a vector over here and you use arctan, You have to use your human mind to say, that's not quite it. So we'll do an example of that. It should have come up in your homework with the complex plane, but we'll see that later. So I leave it, and textbooks do leave it this way too. Arctan, I'll make a note here. Make sure theta is in the correct quadrant. And that's going to depend on your shift. If you're not sure about that, give me a few minutes. But addition of vectors, mad simple. If you think of the earthquake story, as I said, you take your horizontal components, add them, your vertical components, add them. And while I'm here, could we subtract vectors? I guess.
If it's a negative.
Yeah, it's just a negative, right? It'd just be a negative number. It's kind of like we did that. So you would just subtract the horizontal components and subtract the vertical components. Maybe it's like the undoing of an earthquake. I don't know. That one I don't have a good story for. And K times V, where this is a number, K is some number, then it's strictly K times X1, K times Y1. And again, the story of a repeated earthquake. So if that earthquake happened 10 times, it would be 10 of these shifts and 10 of these shifts.
Can I ask why, sir, by the end, instead of like writing the arrow?
Yeah, that should not be a parenthesis.
Yeah, because I thought you were gonna like say something about that, like if you add vectors. Or,
No.
okay.
All right. So that's that. While it's on my mind, find the angle and magnitude of, let's say, -12, +12. All right, so I'll call this V. Oops. Here's where we're not going to have an issue. -12 squared plus 12 squared. Simplifies to this. Check on a calculator. 144, 144. You have two. I can talk it out. 144 plus 144. That's repeated addition. So 2 times 144. But the 144 comes out as a 12, and the 2 stays inside. There you go. Wrong. What I'm about to write. Tangent of theta is y over x. Well, that's actually not wrong. That's correct. Tangent of theta is arctan of 12 divided by -12. Wrong. Because this makes, I already know what it makes, -45 degrees. That's -1. And arctan of -1 just should have this in our memory close enough, but arctan of -1 is -45 degrees. However, if we think about, think about this earthquake, it's 12 units this way, 12 units this way. The angle of this is right here. It's always similar to the complex plane, made with like the positive x-axis or the positive real axis. And that's how we would rotate, right? So if you're like, what's the angle associated with it? It's right here. It's this guy. It's like if this is your starting point, this would be 0 degrees, and we want to say end up over here. Rotating down 45 degrees does not get you there.
Can we do arc
Actually, that would work. That is a correct answer. Because cosine would return a quadrant too. So now that you have this, you definitely could use our cos or our cosine. All I want to say here is yes to that, but how can we correct this? It is arctan. But we just have to add 180 degrees.
Or it's in this case, subtract 180 degrees.
You could subtract 180 degrees as well. Either way, so you don't need. I'll come back to this page.
You're getting the same result.
The coterminal.
Yeah, so if we're over here, so the actual angle is 135, which if you extend this line, by the way, the reference angle is 45 degrees, and I'll go back to like 10th grade geometry. You heard something of vertical angles, boom, boom. So there's a pair of vertical angles right here. This is, you don't have to add this to your notes. This is like just emphasizing something. So vertical angles, 10th grade geometry, this is 45, and this is what our calculator gave us, negative 45 degrees. So how do you take your arctan value and find the quadrant 2? Well, look, this is a line. So you add 180 degrees. So if I'm here and I want to rotate 180 degrees, it'll give me what I want. And David's saying you could subtract 180 degrees, which just is a clockwise rotation. So it'll still get you there. Those would be two different rotations. Mine is positive. David's would be negative, but it's still the angle associated with that vector. And usually we give the positive, just what we do. Whoa. All right, so in summary, that's where we're at. Just be careful when you're finding your angle that the actual positioning, just like a complex number, is in the right quadrant. All right. Okay, let me keep track here. Scalar multiplication, sum of difference, got that. I talked about multiplying two vectors, but I'm going to table that just for a minute. Actually. There we go. Okay. Right off the bat, because you might be thinking it, this I, not at all related to complex numbers. And it's unfortunate that we typically teach vectors and complex planes right back to back. Order really doesn't matter. Sometimes vectors are taught first, then the complex planes, but it doesn't matter. This is not at all related to the I. So the I in algebra world or complex number world is called the imaginary unit. This I is a vector, which has two parts to it, a shift and an angle. So this is really just, what's the magnitude of I? 1. You can almost, right, you should be able to visualize it. That's an earthquake that just took this house and moved it this way, 1. So its magnitude is 1. What's its angle? 0 degrees. Yeah. What's the magnitude of J? 1. What's its angle? 90 degrees. It's a 90-degree shift. 90-degree angle. I don't want to say shift. 90-degree angle. So, cool. I'm not even going to do that. Because we just did. I'm not, no work to show there. Mental.
Did you use the I half J half notation?
So side note.
Oh, the screen just.
Why to do that? Vectors, as I said, are used in a lot of different sciences, and they have, therefore, a lot of different notations. So this is the same as sometimes you'll see a reinforced or like a bolded V. Sometimes we write it like this. And where I'm going with this, sometimes we write them as I'll make more sense of this in a minute. Oops. And David said sometimes you'll see it like that. Which, when I was a learner, thought all of those were different things. But my analogy is, if this is water, this part of the world calls it agua. In France, I don't know what they call it. And in Poland, I should know because I'm Polish, but I don't know. And in China, they call it something else. But it's all the same element. It's literally the same object. It's just different. So our textbook uses this, and this, but you might see it as a hat somewhere else, as David said. Okay, so back to this slide for a minute. And I kind of spoiled something. Not a big deal, though. Okay, so wicked easy. Write this earthquake using I and J vectors. So this earthquake took a house and shifted it 12 units east and 5 units north. If I have to write this using, what were these magnitudes? Each one of these were 1, right? And this is 1 unit east. So I would need 12 1 unit east earthquakes. Terrible. I would just want it all at once, I guess, out of the way. Maybe I don't know how. No, maybe 12 ones would be fine. All right, enough of the earthquakes. But the idea is it's this. Done. Make sense? Going, actually, overkill, but if we take this 12 times 1, 0 plus 5 0 1s, we would get 12 0 plus 0 5. Scalar multiplication, multiply. K times your x and your y is kx, ky. 5 times ky, boom, xy, boom. 5 times x, 5 times y. And then how do we add two vectors? You add their horizontal parts and their vertical parts. So yeah, this is exactly, it's kind of like checking my work. That's why I say overkill. This is written as that using I and J vectors. And it's the most common in our textbook. You will see in some of your homework, because I made sure it was in there, the other notations, but really at some point this becomes what we're going to use as our go-to.
So on the exam, so for the vectors, this problem specifically, when you have like a mirror image of this problem with different numbers on the exam, like you would just write the answer without showing the word.
Yeah. Oh yeah.
Right? Because this is like basic.
Yeah, not going to be on the exam. I'll tell you that right now. We're learning to walk before we run. The run will be on the exam. This is all the walking. This is just getting everyone on the same page.
Yeah.
The running hasn't started yet. But we're about to start running. Here's a good exam question. A house, that's how I think about this in my story world, shifts to this position. So the point 1, 2 shifts to the point -3, -1. Write a vector representing this shift using I and J vectors.
Would it be -2, comma 1? Well, -2i, comma 1j.
Yeah, how did you get it?
Oh, I just added the two x's and added the two y's, and I put the I with the x.
You ever heard of a phrase rise or run put together? Yeah. So you did it. Simple example, intentionally, but in general, what if the numbers were like 7.6254 and -79? Like that'd be a little bit harder to do. So what would you do on a calculator? You would actually calculate their run. So x2 minus x1, in this case, -3 minus 1. And that's good because we started at 1 and we shifted backwards to -3. So that's 4 units backwards. So you got to make sure you take your ending, like your, we call that the head of the vector, and that would be the tail. But this is like the start, the end. This has to be your end. This has to be your start. There's your horizontal. And then your rise, in this case, same idea. y2 minus y1. -1 minus 2, -3. And so this is -4i. And then we could just write minus 3j.
Wait, you don't put a comma? Because earlier when you were like giving us example about the I and J, you put comma -3. Oh,
Because I'm not in that notation world anymore. We're not in that part of the world. That's why I'm saying use the I and J notation. But if this is called component form. And this is I, J notation form. Common, 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 common. I mean, they're all common in our textbook to get started. As I said, as a learner, it overwhelmed me. I literally could not make sense that it's the same thing. Now I do, and I had to say to myself, it's like a language, as I shared with you earlier. It's H2O at the end of the day. How you say it depends on kind of what's asked of you, where you are. But good kind of cycling back to that idea. What's the magnitude of this vector? How much? It's 5 again, right? Yeah. I'm really good with coming up. So that squared is 16. That squared is 9. Add them together is 25. Take its square root. Good old 3, 4, 5 triangle. And what's its angle?
You could do tan for this. So.
You can always do tan.
Yeah, I know, but
Is what?
There's other, like, you do sine, cosine for other ones because they're faster ways, but -3. Yeah,
Y over X. Make sure you do the rise over your run. Tan is slope. Do we need to add 180?
No, we don't. We don't because it's in quadrant 4.
Because it's in
I know
quadrant 3.
quadrant 3, so you would have to add actually. Yeah, will be 180.
And I'm not even going to turn to a calculator. That's an exact answer. That's why that's an exact answer.
Boy, so are these problems like no calculator based, or are they calculator?
If it asks for an exact answer,
If it asks for an exact answer, that's it.
Okay.
if it asks for an approximate, then you'll write in the 36.8 whatever.
So I said on a final exam, this would be like a open response question that has 3 parts. You're because you always ask about like what could I don't know if it is. I'm just saying this is like an exam question in an open response question where I would say like here's 2 points. What is its IJ form? What is the magnitude of that vector? And what's the angle? And I'm definitely going to ask a question that's not in quadrant 1 or 4, most likely,
So I know
if I were to kind of,
questions.
because I'll make it like 3 points and you get 2 if you write arctan 3/4, but you lose a point if you
So I know in the homework
don't add the
questions,
180.
They're just questions wasting time because you got to plug this in. You already found the true answer, the final answer, but go plug it in, for the final result.
Got you. Everyone good so far? Kind of follow along. A little dry, but yeah, it is a little dry. It shouldn't be hard. It's not meant to be hard. It's just kind of new things. We're good with that. We're good with that. We're good with that. Scalar multiplication, properties, unit vector. Okay. Not much more. So this is one of 2 last things. So first objective that we need to do, kind of just in this intro to vectors. And that's all we do in this course is intro to vectors. So let me rephrase that. We actually have like 4 more things to do, but this is one part of your homework. Everything here is in one homework. And then I'm going to go back to what's a vector times a vector. So that's what we got left in terms of vectors. Find a unit vector in the same direction as a given vector. Suppose, going to stick with this. Is this vector V. So this earthquake is 3 east and 4 norths. I'm spelling it wrong. How am I not? Similarity. Yeah, that looks right. Similar, SIMI. What am I?
That's correct. I think that's correct.
Why am I blanking out? Typical math teacher. Silarity.
Yes.
There we go. Apply similarity from geometry. Oh, second geometry conversation. All right, there's a formula coming. But before I give you the formula, this is where the formula comes from. Anyone remember similarity from geometry? No. Well, here's your quick review. 3, 4. Here's vector v. But it's like a triangle, right? For all intents and purposes, let's just call this a right triangle. What's the magnitude of v? 5. Everyone good with that? So right now, the magnitude of v is 5. Here's its direction. I'm going to tell you, we don't actually need to know that angle. We don't need to know it. I want a vector, a unit vector. This is what I want. I want this right here. It's in the same direction, but it's not 5 in magnitude. This is what I crave. How do we find that? Well, go ahead.
I was going to say it's possible to. So we know that tan is sine over cos. Because of that, can we incorporate 4/5 over 3/5?
It is. It does. It is going to be 4/5 and 3/5. But this also comes up in calculus often. When you get to calculus and you do the cone question, you don't need to write this down. Detour 1 commercial break, trying to keep minimal commercial breaks for their time remaining. But you're definitely going to attack cone questions in geometry.
Are they hard or not really?
Can be. Where your cone has a height and a radius, right? And it usually wants to talk about how fast something is pouring into this cone or leaking from the cone. So there's like another level down here. And you need to know something about that water level. But this right here is like this right here. And this right here is like this right there. So this idea of similarity is not taught in calculus unless I teach it, because I try to make connections over and over again. Some students like it, some students hate it. Some of us just want to know what to do, and some of us want to understand why we do what we do. I always teach why, at least to some level, why we do what we're doing. As I said, I'm going to tell you the formula in a minute, but it really boils down to similarity. And from geometry, 2 triangles are similar if they have 2 common angles. So these 2 triangles both have a 90 and they both share theta. And so that just means, again, that they're a scaled version of each other. One is a larger version of another. So if this hypotenuse is 1, but it's been scaled to 5, what was this base so it becomes scaled to 3? Okay, hear me out again. I'm taking 1 and I scaled it to 5. That means I multiplied it by 5. Then what is this what is this base? What is this x? So that when I scale it by 5 becomes 3. When I multiply by 5 becomes 3. And that's what Roman said, 3/5. 3/5 times 5 is 15/5, which simplifies to 3. And if this y value is something, but it's scaled to become 4, and it's not just scaled, it's scaled by times 5, what would it had to have been? 4/5. What's an even easier way to think about this? Let's scale it down. What would I take 5 by? What would I multiply 5 by to scale it down to 1? Multiply it by 1/5. So if I take 4 and I want to scale it down, you multiply it by 1/5. You get your 4/5 this way. Same argument with the 3. So similar triangles and scaling, literally the same thing. What we've just done is the unit vector in the same direction is the original vector. Oh, my bad. Multiplied by 1 over the magnitude. Isn't it? Let's see. Here's my original vector. Boom. Here's its magnitude. And what I crave, we're just going to take those components and we're going to multiply it by a number, 1 over the magnitude. And we're going to scale it downwards. V on top of its magnitude. So to put a little closure to this, oh, my bad. That's the understanding behind it. Is it a hard problem if we redo it? Someone give me a number.
7. 6 and 7.
Here's a vector. Find a unit vector in the same direction as it.
Could be 7 over 2 and 3 plus 3.
All we need to do, either study the formula, but I think of it as, all right, I have a triangle and I need something smaller. I want to know the magnitude of that big triangle. So that's the first thing I need. And now I'm going to scale the horizontal component by 1 over square root of 85. Does that make sense? Because right now the hypotenuse is square root of 85. How would I make it become 1? Multiply it by 1 over square root of 85. You don't need the picture, but for the last time I'm drawing it, this is the original. This is what I crave down here, this small one. So multiply it by 1 over square root of 85. But that means we're going to take this y and scale it by 1 over square root of 85, and this x by 1 over square root of 85. So v over the magnitude is 7 over square root 85 I plus 6 over square root 85 j. Or if you're in this part of the world, 7 over square root 85, comma, 6 over square root 85. I didn't specify which one I wanted, so I'll just write them both. There's your answer. You don't need the triangle. I went through it to make a connection to the future Cohen question you'll see, to reinforce similarity, but from now on, I'm moving on from it. What's up?
Is it possible on final exam know how you gave us like extra credit for like running quickly all the units on the unit circle. Is it possible you could give us like extra points if you relate all three of the like
No.
typical triangle problems?
Next. No more questions about the final or exams. Ask me questions about content. Okay. Finding a unit vector. But since you're speaking of exams and you love applications so
Of course,
much,
I love them. Of course.
Where's he gets there?
everyone's favorite forces. Capital F bolded 1 and F2. What unit are forces measured in?
Is this physics?
Yeah.
Oh, I didn't even take.
I thought joules too. Can you use pounds?
It depends on where you are and what you're measuring.
All right. So it's kind of like, good answer. Are you in Spain or England or China? Our textbook uses pounds. I always thought it was joules though, but okay. I could be wrong. It's been a while since I've had.
I mean, you could also use, you could use
Yeah, they can
watts,
use
you could
anything.
use velocity, you can use.
Use it.
That's going to be a typo.
Horsepower is a unit of force. Foot pounds torque and horsepower. Torque is directly related to acceleration and velocity. You want to cover accelerators in the next test?
All right, this is the most writing of the day, I promise. Well, we still got a lot of writing, but for one problem. All right, done. Yeah, a physics application. And I'm not going to say I have any recollection of my physics, although I did take it as an undergrad twice, like 2 different. Actually, the first time I did have to retake it, so I've taken it 3 times. Physics 1 twice. Side story: when I was in high school, I was in a really bad car accident during physics, so I was rusty. Second, I'm going to blame the professor like everyone does when they get a bad grade. And so I didn't come into college with a strong foundation. Two, the professor was pretty tough. But the second time around, kind of like you, I was striving really hard. And like I went to him after the final exam and I was like, how did I do this time? And he's like, cranky. But he's like, I don't think I've ever seen this. You only got one wrong on the final, like one multiple choice question wrong. He's like, you shouldn't be a math teacher. I want you to be a science teacher. And like literally he became like the worst, meanest guy ever. And he like sat with me for a half hour saying like, don't be a math teacher, become a science teacher. And I was just like, I just want my grade, dude. Like I don't like you. I just want to make sure but I was like adamant about like getting a really good grade. So
It's
anyway.
possible we could translate the degrees and right hands will be easier.
No.
Or
No, it won't be easier.
It won't matter.
Nope.
No correlation.
My whole point in that side story was I'm going to trust that if you have two forces acting on an object, then where that object ultimately kind of ends up is basically called a resultant force, right? And it's going to be found by the adding of these two forces together, like the resultant force. In a way, I can make sense of like if I have an earthquake shifting this way and an earthquake shifting that way, I feel like the resultant is going to be somewhere in between them. Like, so that's about as much as I can remember. And I'm just following an example pretty straightforward here. So we have two forces. Force 1 has a magnitude of 30. Force 2 has a magnitude of 60. Acting on an object. Next thing. This should have a north here. I erased it. Sorry about that. Anyone have any recollection about bearings from a trigonometry course? This is a bearing, right? So it's a direction, and I'll show you if you've forgotten what they are, but I'll remind you in case you need a little more refresher. You would just look this up on a YouTube video, type in like, what is a bearing? And you can probably find a 5-minute or less video, but I think I can do it as quickly. So this is an angle, but it's a very specifically drawn angle. It's like, do not think about standard position anymore. Literally follow what the bearing tells you to do. So the first is going to be either north or south. I guess it could be west or east, but in our textbook, it's always either north or south. So it says, okay, imagine facing north. The second is a number, this time degrees, and it's going to tell you how to rotate and to which side. So you're now going to say, from here, rotate 10 degrees. But again, this is not, you do not think about, it's the only time you don't think about standard position. You're saying you're going to rotate 10 degrees towards the east direction. That's it. So towards the east, 10 degrees. This angle down here tells us to face north and rotate 30 degrees towards the east. That's probably too big, but something like that, right? So here's the angle right here. That's what a bearing is. Good opportunity just for quick side story. What would south 37 degrees west look like? Face this way, rotate this way, 37 degrees. That's all a bearing is. Tells you how to face and which way to rotate from there, either west or east. Okay. Does everyone have the whole prompt copied yet? Yeah. Anyone still writing? All right, let's visualize this for a minute. So here's my object. And so here's north. Here's 10 degrees towards the east, not drawn appropriately. and that's F1. Here's north. Here's 30 degrees. And this had a stronger magnitude, just means a bigger length. So I'll do something like this. There's F2. And what we crave is the resultant, which is going to be just estimating in my mind. If something's pulling that way, if that was the only thing pulling on it, it'd be going that way. But this force is pulling on it this way, and it's pulling stronger. So it's not quite right in the middle, because if they were equal strengths, it would definitely go right in the middle. That's just my human sense of it. But this is a stronger force. Like, that's its magnitude. It's got more force. So it's it will be pulled, generally in my mind, something in that direction. All right, so we have an idea about this. What we need to do is, one, write F1 in IJ notation. We already know what this is. $30. No, that's not true. Oh, no, that is true.
What do you subtract 30 from 10?
Hang on, I got sidetracked for a minute. What's up? No.
If the forces were equal, yeah, sure, but they're not. So no.
However, here's where I was getting paused for. I'm like, what am I messing up here? I'm not messing anything up. However, this 10 degrees is not, right? So the picture is correct, but it's not how we want to write our I and J notation. I and J notation is always made with the like it is made with standard position. So let's just look right here. If this is force 1, what's the angle right here? 80. Yep. So I'm going to draw a picture over here using 80 degrees. And force 1 has a magnitude of 30. Then what is this horizontal component? And what is this vertical component?
30 cosine 80 and 30 sine 80.
So also a connection from our last lesson, or just trigonometry in general, and you could chime in here. If we know an angle and I want to know the base here, we could say cosine 80 is x over 30, but then we would multiply by 30, and that's how we find our x coordinate. Why did I say that's a connection to our last unit? Because when I was talking about the polar form of complex numbers, I said the x coordinate is the radius times the cosine of the angle. So there's also a connection to the complex plane. This right here is going to be 30 cosine 80 degrees. And this right here is going to be 30 sine 80 degrees. So the magnitude of the first is 30, but that angle is not the direction that we want. It's not made with this positive horizontal axis. So we have to find its complement. I think it was Hashim said 80. And now to find the I and J form, we need this X and this Y. So use trigonometry or use the connection polar form. X is 30 times cosine of that angle. Y is going to be 30 times Y, sine of the angle. There it is. Magnitude of F2 is 60. That was told to us. But I need to think about this as my angle. If this is 30 degrees, what's the complement of 30? 60. What is this X component going to be? 60 cosine 60. What's this Y component going to be? 60 sine 60. What color did I use? Green? Take and add the two vectors to find the resultant. You take the horizontal component, add the horizontal component. It looks abstract, but earlier when I said the shift was 12 and then 3, or whatever numbers I used, you said it was 15. So that's really it. This is like the first horizontal shift and the second horizontal shift. Same argument to be made with the vertical shift. Putting this into a calculator, it would be time consuming, but I'll do it anyways. 80 cosine, not 80. I knew that was wrong. Clear. 30 cosine 80 plus, what was it? 60 cosine 60. So what did it say? To the nearest hundredth, we would use about 35.21. And I think I can be sneaky. Change these to sine pretty quickly. It's probably not going to work. We'll find out. A. $81.51 rounding appropriately. So ultimately, this resultant force would be, and I'm just going to use whole numbers, about 35 horizontally and 81 vertically, just using the whole numbers. But obviously, the question asked for nearest hundredth, so I've expressed it that way. That was what would happen to that object. It's same as question 1. All we're doing is writing it in its I and J notation. Force 2 is this. We already have its magnitude, but what I wanted to be careful of is when we write it in I and J notation, we have to consider its position starting with the positive x-axis, because that's just how I and J notation it's considered to be from the positive horizontal axis. So a bearing is not in standard position. I and J tells us how much we go from here, from like our starting point and up. So I need this angle right there, which is the complement of what was given, 60 degrees. And then the horizontal component is the magnitude times cosine 60. The vertical component is the magnitude times sine 60, or whatever that angle is. That's like your polar. There's a connection to polar form there. Tangent of theta, we would take the horizontal component, 81.51. So actually it is an approximation, but will be good enough. 81.51. Put it over your horizontal component. Do I need to add 180 to this answer? Nope. Oops. Oh, that's not going to be right. No, I did have it right. Divided by 35.21. Hey, what did I do wrong? There we go. My answer did not seem reasonable there. 0.04 degrees. No, that didn't make any sense, just based on what I knew from the diagram. To the nearest tenth, 66. Ooh, sign of the devil. 66.6 degrees. And remember, inverse tan, as I said before, gives you the negative quadrant 1 or the quadrant 1. This is in quadrant 1, so we don't need to add anything there. And that wraps up our intro to vectors. Yay. Well, that's the intro to vectors.
I asked.
Yeah.
What's going to be the hardest unit on the 6 a.m.?
The one you don't know the strongest.
Yeah,
That's true.
I mean, like, what we're learning, that's going to be less difficult.
The one you don't know. The one you don't understand. If you understand it, everything's easy. Quantum mechanics is wicked hard to me, but not to people who understand it.
So they're saying like everything's pretty equal. Everyone should similarity.
I answered your question. Which one's going to be the hardest is the one you don't know.
Okay.
Very dependent on you.
Okay. The dot product. That just switched. Why did that just switch on? Earlier asked a question. Does 2 times a vector make sense? Yeah, it just means that poor city got hit with that same earthquake twice. And 20 times a vector, does that make sense? Yeah. 20 of those earthquakes hit it. But does this make sense? Suppose I'll just do 3, 3. Obviously, it's a question. What the heck's the answer? One earthquake times another earthquake? I mean, just my tone of voice there, I can't think of an interpretation of it. Again, if I have two different earthquakes, I can say this one hit, or this one undid that one, or I can do 5 of the same earthquakes. But an earthquake times an earthquake? In regards to earthquakes. Earthquake times earthquake. This is not scalar multiplication. We call this the dot product, not scalar multiplication. And I'm not able to make sense of it. I'm not kidding. Every time I teach this, I go to Numberphile and I type in their video on dot product for hope, for that I can still say, how can I make a story out of this? And in 16 years, I still haven't. You're waiting for something. I don't have anything. I'm not lying. I don't know how to make sense of it. But it is this. V times U. I'm slightly lying to you. I do know how to interpret it, but it's pretty, I'll leave it at that. I need this notation. Oops. So basically, here's our horizontal components for 2 different vectors. And if you're asked to find their dot product, it's A times C plus take their horizontal components, B times D, multiply them, and then add AC plus BD. That's it. Super common question in a true or false question, in a true or false section. The dot product is a vector. False every single time. True or false, the dot product is a number. True every single time. When you multiply, this is just strange. A vector times a vector, you do not get a vector, you get a number. Find the dot product of V times U. Just make sure we can apply it. Take our 2 horizontal components, multiply them. Take our 2 vertical components, multiply them, and add. 14 plus 4 is 18. Simple, but I don't have an interpretation for it yet. Definitely not with earthquakes. Dot product. Next time we meet, I was hoping to get to it today, definitely not happening. we're going to talk about matrices and kind of end this world of, I don't know what to call it, well, additional topics of trigonometry. And then we end with algebra, exponentials and logs. Kind of like, feels like way out of left field, but probably one of the most important things for calculus that students struggle with. But I'll let it go. So I bring up matrices because when we multiply matrices, it's going to have a similar vibe to what this dot product is. So it's simple, but we're going to extend it into like 3 dimensions or further. So if you have some time, I would try to get your homework done. It's simple, but it'll just give you an opportunity to make sure you practice it. I end with this today. The angle between 2 vectors. And I was going to take the long road with it, but I'm going to jump right to the formula. One thing I want to emphasize, what we're ending with today is finding the angle between 2 vectors. Not to be confused with, I'll use that physics application, like the angle of the resultant. That's not what we're finding here. Imagine, although it does make sense in that context, but what we're really about to find right here is here's force 1, here's force 2. Let me actually go to the picture. What I'm about to find is this angle right here in between the 2 forces. Not what we found, which was the resultant's angle. I point that out because so many students make that error in what we're finding. The angle between 2 vectors is the dot product of the 2 divided by the product of their magnitudes. Why does this random line just appear? To find the angle, first setup cosine is find their dot product. Just remind you, horizontal components, 4 times 1 plus negative 3 times 2. So we have 4 plus negative 6. That's negative 2. And divided by the product of the magnitudes. 4 squared plus negative 3 squared is 25. Take its square root. All of this becomes 5. And 1 squared plus 2 squared is 5. Cosine theta is negative 2 divided by 5 root 5. Therefore, theta is arc cosine of negative 2 5 root 5. And here's where I end in a second. No, I'm a minute or two over, or yeah, actually, according to this, 1 minute short. Our cosine of -2 divided by 5 root 5. 100 point whatever accuracy level they want, but I'll say to the nearest degree, 100 degrees. See you on Thursday.